Alright girls, I decided that it might be a good idea to create a video so I can help you with your evolution lab tomorrow. In this lab you're going to be making origami birds, and we're going to use those birds as a species and study the effects small mutations can have on their reproductive success over generations. So one of the first things you have to do is you have to measure accurately the wings, and the wings are going to be 20 centimeters long and 2 centimeters wide. Now, it's really important that you're accurate with this so that you get the best results. And I've measured across 20, and then the width is 2. So you'll actually cut 2 of those strips out, and one will serve as the front of the wing and one will serve as the back of the wing. In science or biology, we call the front anterior and the back posterior. Now, you notice that's 2 centimeters wide and 19 centimeters in circumference if we overlap it that centimeter. Got it? So, you need to take a piece of tape and you need to tape that together real nice and neatly. And the amount of tape that you use is important. I mean, you're introducing a new variable if you don't try to remain consistent, but I don't want you to waste lab time tomorrow trying to measure out, 5 centimeters of tape every time. Now, the wings are cardstock and the body of the bird is going to be a straw, and since we need to know what's the head of the straw and what's the tail of the straw, thought we'd make him a little beak. Makes me happy. Now, you'll see the markings on the body, 3 centimeters. So 3 centimeters from the anterior end and 3 centimeters from the posterior end, you will actually tape the wings. Now, what we are creating right now is the original parent bird, generation 1. And you'll note right there in the video that I'm taping right at the line. This parent bird will produce in the first generation 3 chicks. The first chick will look exactly like the parent bird, same width wings, same circumference wings. Chicks number 2 and chick number 3, chicks number 2 and 3, in other words, will have certain mutations in their wing size or wing placement. Now, before we ever go through the process of creating generations, we need to take this parent bird out and we need to fly him to see how he flies. So we have a line marked on the carpeted floor. We're in a wide open area, and whoever the flyer is needs to remain the flyer for the duration of the lab. So you very carefully throw it. You don't need to throw it hard. It's actually better if you throw it soft, and you measure it in centimeters and convert to meters and put that on your data table. Now, the mutations. Mutations occur by chance, changes in DNA. You flip a coin. If it's heads, you're going to make the change to the anterior end of the bird. You'll then roll a die. Whatever the die lands on, you will make a certain change to that bird. And on your lab, you actually have a list of those mutations that could potentially occur. Now, I'll be honest, this part of the video is a little fuzzy. But if you look at number 2, or the die there, we know that it's going to happen to heads, by the way. You look at 2, and it says that the wing position moves 1 centimeter towards the middle. So instead of the bird wing being 3 centimeters from the middle, it's going to be 4 centimeters from the middle. You will fly all 3 chicks and determine which one flies the farthest. The one that flies the farthest will have the most reproductive success.